Let's continue our Calculus 2 review. So Calc 2 review. This is part 7. Part 7. Now, for this one, I want to look at a problem. It's listed as number 54, and it says to find the area inside one loop of a lemniscate. And the lemniscate is r squared is 8 cosine of 2 theta. Problem with r squared and the calculator is that it's not going to set up quite correctly. So here's what I've got set up. I've got plus the square root and I've got minus the square root. Now that's great, except that sometimes it's defined and sometimes it's not, because I have got to have the cosine of 2 theta as a positive number, or r squared is not a real number, and we need to have that. All right, so when you look at the graph of this thing, and I've already done this, but it's right here, it's partly the first function and partly the second function. Not only that, I've got some kind of crazy bounds on it. I've got negative 2 pi to positive 4 pi or something, so it kind of duplicates somewhat. But I go nosing around on this thing, and if I trace, I notice, and I've already been in here obviously, because it's not starting at the beginning, but if you start at minus pi over 4 and you trace constantly here, this is one that goes all the way constantly, it goes to 0. So I could get that little quarter of this lemniscate, which it asks for one loop, so it's actually half of my lemniscate. So I'm going to evaluate from there. Now we're underneath, so we might catch a little bit of the error in that, but we can take care of it. So let's find the area from minus pi over 4, which is over here. Okay, let me plug in minus and then pi divided by 4. Okay, so minus 0.785398. I just recognize that. So let's check that out. Okay, so we're going to do the formula for polars is 1/2. So we're going to go minus pi over 4. That's where we're going to start, and we're going to stop at 0. And then we've got to have r squared d theta. That's the formula. So let's check that out. R squared, that's already done. So what we end up having here is 1/2 the integral minus pi over 4 to 0 of 8 cosine 2 theta, since it's already squared, d theta. This will cancel a little bit. I can pull the 4 out. So I've got 4 times, and then I've got the integral. So this is actually an easy integral to solve. Got cosine 2 theta d theta. It's the boundaries that are hard to find, and I kind of had those set up for you. So cosine 2 theta, integral of that is sine 2 theta over 2. So we've got 4, and then sine 2 theta over 2. Now I am using substitution, but not showing you all the work. U is 2 theta, du is 2d theta, and we don't have a 2d theta, so we've got to divide by it. We could have had one, but anyway, I did substitution. Okay, so we've got to go from minus pi over 4 to 0. Now, clean that up a little bit. If I put 0 in here, sine of 2 times 0 is 0. And we need to subtract. What's the sine of 2 times minus pi over 4? Well, 2 times minus pi over 4 is minus pi over 2. Okay, the sine of minus pi over 2 is 1. So there's that. Okay, I lost a factor of 2, so I better go back and find it. So I get 2 times negative 1, which is, or I had a negative there, 2 times 1, which is 2. So we did not have to make any adjustments for going through the bottom part of that. But finding the bounds is the difficult part, and I think the calculator is a lot of help there. So let's go on somewhat and see what we can come up with on these problems. Lots of area things. Okay, so let's find a standard form equation of an ellipse. So this one is number 56. I'm skipping a few here. Standard form equation of an ellipse that is centered at the origin and satisfying the following conditions. It's got vertices at 0, plus minus 7, and foci at 0, plus minus 3. Okay? So, with an ellipse, we've got a relationship between values that are A's and B's and C's, so we've got to deal with that. Now, let's kind of go into this. They never tell you all 4 vertices, they just tell you the ones on the major axis. So I'm going to come out here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and the focal points 1, 2, 3, and 1, 2, 3. Now these distances are called C's, and I never really pay attention to whether these are A's or B's, but we'll get there. I'm going to call that like an A. I think it's an A in most books. Now, the obvious thing maybe is that the vertical that's going to be here and here is going to have to be somewhat shorter because this is the major axis. So it's going to have to be smaller than A. So how do we get something smaller with a Pythagorean kind of relationship? Well, we need to subtract. So let's say that we've got A squared minus C squared equals B squared. Okay, so A squared, A is 7. Okay, center out. I shouldn't have made it look like the whole thing, but it's going to be 7 squared. And then C is 3, so minus 3 squared. So we've got 49 minus 9, so we've got 40. So B is going to be the square root of 40. So this is B squared. So B equals the plus or minus the square root of 40, which we could simplify a little bit and say, well, it's 4 times 10, so that's 2 square roots of 10. So 2 square roots of 10. Square root of 10 is a little more than 3, so this is a little more than 6. So we'd go 1, 2, 3, 4, 5, 6, and then just a little past, and you could kind of draw your ellipse. Okay. But the question was to write the equation. So I'm going to write the major axis part first, that is x. So x minus the center, the x part of the center, so that's 0, squared. Over the distance you go in x, squared, so 7 squared. Plus, ellipses are plus, then we've got y minus the y part of the center. Well, this is centered at the origin, so we don't have anything going on there. And then the b distance is the square root of 40, so you square it and you just put 40. Okay, I could have put 49 there. And this is equal to 1. So there's your equation for that. Let's see here. A parabola, number 57, says find the directrix and the focus. This is not college algebra generic stuff here. It's got y squared minus 24x is equal to 0. Now, the formula that is used a lot is one that solves for the squared term. So I'm going to do this. Y squared equals 24x. Okay. Then the formula is you've either got x squared or y squared here. This one's y squared, so it's going to open sideways, but it's equal to 4p and then x minus h. Okay, this is going to be y minus k squared, and this is 4px minus h. That's a standard format. It's not your college algebra format, though. And hk is the vertex. Well, okay, so the vertex is going to be at 0, 0. That's nice. But 4p is 24, so p is equal to 6. Okay, so let's check this thing out. This will help us figure this out. If we have a vertex at 0, 0, 0, 0, let's pick a value for x and make it y squared, or pick a value for y and figure out what x is. In fact, that might be a little bit easier, right? So let's pick 1 for y, okay? So if we've got a formula here, here's x and here's y, we normally do it that way, although we're picking this. So y is 1. So y squared is 1 is equal to 24x. 24x. Okay, well, what's x? Okay, y equals 24x. So x, y squared equals 24x. So then x would be 1 over 24. Okay, 1 over 24. But what if y happened to be minus 1? Well, if y is minus 1, then y squared is still plus 1. Okay, so that's going to make 1 equals 24x. So this is going to be 1 over 24 also. Now that's the part that we're not as familiar with, because we're used to functions of x, not functions of y. So if I put 1 over 24, it's right here maybe, I've got to go to plus 1, and I've got to go to minus 1. Now that gives me some really good info, because it makes me realize that my parabola is opening to the right. Now there are some things you can kind of use from books and memorize and such, but that's going to help a little. Okay, so where's the focus? Well, the focus is inside the parabola, so it's got to be 6 units inside the parabola. So 1, 2, 3, 4, 5, 6, and I know I called that 1 over 24 before I messed up here, but out here at 6, 0, we've got a focal point, focus. And this way, 1, 2, 3, 4, 5, 6, we've got a line that runs like this, so it doesn't run into the parabola, runs vertical, and this is the line x equals minus 6, and that's called the directrix. So since it opens to the right, the directrix is off to the left. Now the big deal here, I guess, is that 4p has got to equal 24, and that p value is a distance. It's actually a directed distance. So you go positive, and then you go negative for the directrix. But you don't have to memorize that if you put a few points in. All right, let's get some other